Good afternoon, everybody. A very warm welcome to the fourth day of second session, 1 week faculty development program on sustainable additive manufacturing in medical applications, UN SDG perspectives, organizing by Lord's Institute of Engineering Technology, Mechanical Engineering Department, sponsored by AICTE Training and Learning Academy from 15th June to 20th June. I welcome you all again. Today we have our chief guest, Mr. Saksham Rastogi. He is Application Manager, Design Tech Systems Private Limited, Delhi, India. He is a BTech graduate in Tool and Die Technology from Delhi Institute of Tool Engineering. He has experience of 10 years in his career. He is a 3D printing enthusiastic working with Design Tech Systems Private Limited, India. He has an experience of 10 years in the field of trending 3D printing technologies and mainstream 3D printing applications. He support industry setup, required 3D printing technologies as per the applications in R&D, tooling and manufacturing. He also provide well-structured trainings and workshops for students and professionals on additive manufacturing. His prior experience in EdTech associated with Indian Institute of Technology, Roorkee. He was serving as a technical officer in Rethink the Tinkering Lab and taking care of 3D printing lab along with CNC, VMC and Bio 3D printer and industrial 3D scanner. He has done his engineering graduation from GG SIP University, Delhi in the field of tool and die. So huge round of applause for our today's chief guest, Mr. Saksham Rastogi. So we welcome you for this 1 week FDP program. The session is all yours. I request you to please take the session.
Hello. Yeah. Thank you. So first of all, good afternoon, everyone. Thank you, the faculty members, directors, and principals of this Lord Institute of Engineering and Technology. Thank you all faculty members for inviting us as the industrial speaker in this particular session of FDP on additive manufacturing. And all the students, welcome all the students who are coming and showing the interest in this new technology, new era of the technology which comes under the Industry 4.0. So we will be explaining about how the 3D printing technology is being enabled to enhance the healthcare industry, not even just the global market, but when we talk about the Indian market scenarios, how our medical professionals, our medical device companies are utilizing this technology in different case scenarios. So when we consider, since I think we are all sitting here with the mechanical degrees and education of the science and technology, but not have a very wide area of knowledge about the human anatomy, how human anatomy works, and what is the relation between our human anatomy and the mechanical engineering. So this is where we will come to explain that what is the relation between when we talk about the healthcare challenges and what in mechanical engineering and our concepts of physics and our mechanical concepts we can utilize with some materials, with some concepts of the mechanical to solve some problems of the healthcare scenarios in India. So just a short. So just a small introduction about us. So we are from Design Tech. We are a 30-year-old company in India, and we are the pioneer. We provide the pioneer solutions in CAD/CAM industries. So we are the official partners in India for Stratasys in 3D printing, and also official partners for the LTR for simulations and for the MATLAB also. So our principal technology partner is Stratasys for 3D printing in India, where this is a dual headquarter company in USA and Israel, and this is one of the first 3D printing technology company in world, okay, who came up with the technology called FDM and PolyJet back in 1988. Okay, so this company started commercialized from 1990 and they came to India during 2005 in India, and from Design Tech they have joined hands to provide the solutions for every industry in India. So Stratasys India, they are headquartered in Pune with their center of excellence, the biggest center of excellence of additive manufacturing in India, in Pune. And also in design tech, we also have the center of excellence in Pune, one of the biggest one, where we cater different technologies in 3D printing for different industries and applications. So I think in previous lectures or sessions, you must have learned about lot of about 3D printing, so sustainable developments also in 3D printing, additive manufacturing with polymers and with the metal 3D printing also, I suppose. But when we talk about the growing opportunities, what are the growing opportunities for you as a student or as a researcher? Okay, so when we talk about the APEC region or APEC region growth, you can see some of the charts here, which shows a very CAGR growth at about 20%. Okay, and the study shows from Financial Express. There is an article I have linked, put up the link there. So they says that in 2022, the market estimation was about $92.3 million. Okay, with a CAGR growth rate of 20.3%, and every year it is growing. And it is not just when we talk about the polymer or metal, it is with all the technologies. And during COVID, 80% of the medical equipment suppliers, okay, they were hit a lot because all the imports were stopped during the COVID, and even after the COVID also. There were a lot of challenges came for the medical equipment suppliers, where we all saw on the news articles day by day in the during uh, the COVID scenarios. So during the COVID time, because of the supply chain issues, lot of medical equipment manufacturers such as the Abbott, Johnson and Johnson, Stryker, Medtronics, even our Indian companies such as Lexier, Oxy and Romsons. So these are the companies who took the initiative, instead of importing any kind of medical equipments, whether it's a manufacturing item or whether it's a surgical item, they started building up in India, okay, under the Make in India scheme, where the government also supported. Okay, so this is how now medical industry is growing for the devices, and that's why the even hospitals are taking interest, okay, to take this technology, and some of the engineering technology institute also, they are taking the interest in the development of medical device companies. So this is a short video just to show you that how the 3D printing technology is enabling the makers, okay, not just the health professionals, but even the engineers to understand, first of all, the language of the medical. When we talk about the medical, without understanding of the human anatomy or animal anatomy or any species anatomy, you cannot develop. First of all, you have to find the problem. You need to understand how that particular joints or how that particular organ is working and what kind of issues can come up. So this video shows you that how different anatomies can be made with very biomechanical accuracies. So I think volume is little bit low, but I will take you through it. So this is a 3D printer, where you have seen that we can paint now multi-materials and multicolor components to highlight the tissues, to highlight the blood vessels, to highlight the nerves with the exact hardness, with the exact softness of the tumors and the tissues. So you can see on the table, even at the table here also, and the screen also, very different kind of the components of the anatomy can be done now. So this is with the help of the engineers who work behind this, to develop the materials, to develop the software mechanisms, to develop the mechanical components of the machine of the 3D printer. right? This is what mechanical engineering has helped to develop such kind of the technology with the help of the medical professionals, with the help of the medical companies. So you can see this is the knee joint. In this knee joint, you can see the skin area and the knee area. And this is a single 3D printed part, knee in the bone materials and rest of the materials with the skin tissue material. So this kind of the skull structure where you can understand the complete anatomy and can understand the issue, that this is where the neuro problems or spinal problems are coming up, so that you can understand the mechanism, understand the challenge first, okay, and you will get to know where the problem is occurring and what kind of solution I can provide with our mechanical solutions. So this is how the product development is working. You can see in the product development section, even the companies, they need to work out first of all with the anatomy part to understand the issue. So this is the spinal part where you can see the screw, implant screw is also fitted, right? So what kind of material will be suitable for it? What kind of forces need to be applied? What kind of machine I need to make to put that implant inside the human body? Okay, you cannot take a screwdriver and screw it inside the human body, or take the hammer and just put it like you are putting a nail in the wall, right? You need specialized medical tools. Okay, the power tools, you need a specialized material. So this is your mechanical knowledge, your mechanical engineering knowledge comes into the picture. So you can see this is the liver part. Okay, I think if anybody of you have seen any pictures of the liver, so this is the 1:1 liver part where the outer area is printed with the transparent material, and now all the blood vessels are visible. Okay, so if you are facing any cancer related issues, okay, where you need to make an equipment or make a medical device where you can use it for the radiology scans or even for the surgery tools, for the catheter devices, also for the cardiac surgeries. For that area, you need to understand the anatomy first, the issues. This is for the maxillofacial models. I think Dr. Ashish must have shown you some many good examples of the maxillofacial surgeries, how he as a surgeon is taking the advantage of the 3D printing technology. Okay. So first of all, let us understand the healthcare challenges. Now, what are the healthcare challenges are coming up in the global market, including our Indian and APEC market also, which is opening a lot of doors in terms of the research work. So when we talk about the model production, such anatomical model production, these are very high costly models which are available right now into the market. And those models, they does not mimic the properties of the bones, tissues, blood vessels or anything. Okay, they are just the solid part which can just be kept on the table and just to show as a showcase. But you cannot have a touch and feel of the material. Okay, so we have such kind of the materials which you can take a look after that. Second thing is to create such kind of the complex. So human body or any living body is the most complex uh, you can say structure which is being made, right, organically. Okay, there is no complex structure except the human body on this earth, right? I think that you must have all know. No robotics can match that much kind of complexity, because our neurosurgery, our cardiac, our blood vessels, or our all tissues, they work in a very, very different manner. So that's why to create such kind of the complex models, you need a very good, accurate and a good mechanical property materials. Also, the another challenge is to do the continuous handling of such high volumes. So when we talk about making the pre-operative plannings methods or for the medical device companies, so suppose if you're working for any kind of a disease, say sleep apnea. Sleep apnea is one kind of a disease where you know uh, your nasal kept open while you are sleeping and you are keeping a lot of noise, and your air, the breathing which you are doing is not proper. So sleep apnea is one of that kind of disease where person gets difficulty of the sleeping, right? And there is a lot of chances that air can get trapped in your food pipe while you are sleeping, and it can block your food pipe, your windpipe. It's the same thing. So it can block it during sleeping, and the person can die. It is that kind of a complex disease. So sleep apnea, it's that kind of a disease. So you need to understand how our trachea, how our esophagus, our windpipe, or food pipe, whatever you say, how it is working while you're sleeping, how it is making contraction, how it is expanding while you are sleeping, while you are taking oxygen, while you are breathing and exhaling, right? So that kind of complexity and working, you need a very good accurate materials, because you cannot take a dead body and do experiments on that, right? So that's why you need a very good accurate material. So those kind of the continuous handling is not there, those kind of properties are not matchable right now into the market. So, and when we talk about the training also in the education, so in education, I mean, if you go to any surgeons, go to any hospitals, there are a lot of issues are there. You cannot touch any patient, you cannot treat any patient also, okay? Even the surgeons who are resident surgeons, they cannot touch the patient directly, because they need to be very much confident, they need to pass a lot of tests before they touch the patient. So this is where our Stratasys healthcare solution comes into the picture with our PolyJet technology, which is a multi-material and a multicolor technology, where you can fabricate any kind of the anatomy plus the related medical device, which are biocompatible with the skin, with the tissues and everything, and sterilizable also, and you can print it on demand. So with Stratasys, we have a 5 different technologies. One is FDM, PolyJet, SLA, Origin, and SAF technologies. So we provide different technologies depending upon what kind of applications of medical you are doing it. So today I will talk about the PolyJet itself. And Stratasys, they have its own medical vertical, which is situated in the Israel as a headquarter and in Minnesota, US, and they work with all the industrial partners of the medical device companies such as Siemens, Abbott, Johnson & Johnson, Stryker, Medtronic, Boston Scientific, Abbott, any name that you take, which is a global company for medical devices. So they work closely, and this is the result of the development where they have come out with such kind of the materials to cater all the problems of the medical device companies for their development of the products. So, Stratasys medical locations, these are the global locations where their R&D team sits, and they do all kinds of the product developments with the association and with the close collaboration with all the industry leaders and the hospitals and the surgeon teams. And this is their medical journey, that how they initiated this technology back in 2016, how they came up with the FDA approvals. Okay, so in medical device companies, you need a lot of approvals. Okay, you cannot just make a medical device and sell it into the market. You need to close a lot of trials, you need to do a lot of government norms also before you commercialize your medical device product. Okay, so this is where the FDA approval also comes, where our printers and materials are completely FDA approved to be used in the hospital, to be used in any medical device companies. And these are some of the examples of the healthcare customers in India who are using this particular Stratasys solutions. So you can see the name on the board, all the worldwide companies, Medtronic, Stryker, Boston, are Indian companies such as Polymed, Oxygen, Romsons, and even some of the educational institutes such as the Savita Dental College and even AIMS Delhi, AIMS Bhopal. So these are some of the customers who are using this particular technology for both patient care, pre-operative planning, and for medical device developments. So let us see how this technology actually works. So this is a polyjet 3D printing technology, which is a patented technology from Stratasys, and it works on the photopolymer resin materials, which cures under the UV light with different intensities. Okay, so this is a multi-material means, you can see here. So there is a print head which works while layering up the materials with the different heads. Every different head jets different kind of the materials. So you can jet 7 different materials at a single time. So this is what multi-material means. And multicolor, you can always put different color materials so that you can take out some colors also into the model to highlight that particular area. So you can see the working here, and this is how we develop all the colored and multi-material models for the anatomies. And this is what specialization comes with our technology, which is why all the global medical device companies and Indian companies, they trust our technology, and also hospitals such as AIMS Bhopal, AIMS Delhi, Savida Dental College, they also trust our technology and our practices, our applications, our materials to actually provide a patient care solution. Okay, it is not a gimmick, it is actually being provided directly or indirectly to the patient. So this is what a change makes into the world. So just a short, I think this all you already know, I think in previous sessions you must have seen also. You take a DICOM data from the softwares, you convert that DICOM data to STL, and you can 3D print it. But what in our 3D printer, what makes special? So in our software, you can choose the materials and the colors in that particular anatomy. So if you see on the board, there is a kidney model, right? And can anybody tell what is special in this kidney model? What do you see? Any specialty that you see here in a kidney model here in this picture? Yes. So I have used different colors. Why have I used different colors? Because there is a tumor. There are blood vessels inside the kidney. Okay, the blood vessels which are connected with the tumor and direct coming out of the kidney, and if the surgeon cuts down that tumor and cuts down the blood vessel also, so there is a lot of damage can be done to the patient. So this is where the complexity comes. This is where the 3D printing technology provides a solution directly to the surgeon or directly to the medical device company, that how you can structure a medical device or a surgical tool which can be easily handled by the doctor, and they can precisely cut down the tumor or precisely can treat the patient. So this is where your mechanical idea comes and a medical professional idea come together, and you make a solution. So in this you can see we can create models such as you can create a single particular model which can show all kind of the capabilities. First of all, your skin tissue, which is a soft material, your bone tissue, which is a hard material, okay, the nerves in different colors so that you can see whether it's an artery or it's a vein, it's a red blood vessel or a blue blood vessel, right? Your teeth, spine with all the combined hard and soft tissue. So we have some spine models which you can check. And you can see on the board here. So I think it's a very good mesmerizing thing that now you can make completely different kind of models in full color, and you can take these advantages for the better understanding. And this is not just being used in medical, this is also being used in automotive and engineering applications, but that's a different topic. So this is our particular software. So that was our technology, but there's a lot of use of the software also. So when you talk about the software developments, okay, we need to understand the whole working. So in our software, we have about 100 plus presets already in our software, where you can just directly choose what kind of anatomy family you can see here. So we have the blood vessel anatomy, general anatomy, heart, and the skeletomuscular. So skeletomuscular means the bone plus your tissue part. right? So those kind of the parameters you can already set with a presets analysis here. And we have all the complete libraries which you can tell the problems, like the blood clotting is there, or if you are making a fixture for the surgery, right, for the tumor, for the reinforcement. So there are a lot of presets, 100 plus presets are already there in the software. So this is one of the most important research and development done by the company to provide a direct solution to the customer. You don't need to put a mind on that. You can just select and choose that this is what I want and this is what printer will give the output. So in patient specific solutions, there are direct benefits to the patients and to the hospitals. So for the pre-surgical plannings, we can improve the surgery outcomes for any complex surgeries, for the brain surgeries, spinal surgeries, cardiac surgeries, or even for the implantation surgery, maxillofacial surgeries. And also we can improve the communication with the patients. Okay, so like as an engineer, as a team, when you talk about an idea, you discuss, you sit on the table, you discuss, you do the brainstorming before you put a hand on the machine or before you start working on the product. Same thing happens in the hospital. The doctor doesn't go directly into the operation, they didn't start operating. No, it's a human body. You're talking about a life. Okay. So here for complex surgeries, doctors, they also have an obligation to explain to the patient, this is what we are going to do. Okay. And this is what kind of risks are involved, so that patient can also feel comfortable before the surgery, because there are a lot of anxiety, lot of internal problems comes to the patient. So when we are talking about a life, this communication helps, and this 3D printing technology helps surgeons to provide that communication. And for the hospitals, yes, there are shorter operating room occupancies and shorter patient recovery times. So when we talk about this particular technology, there is no limitation in any kind of the anatomy. You can work in any particular area of the medical research or medical device companies who works for neurosurgery, for cardiac, okay, for dental surgery, for cardiovascular, for digestives, for urology, musculoskeletal, orthopedic, any kind of medical device companies who are developing direct surgical tools or any medical device solutions. Even if it's a BP checker or a sugar test checker, that's a medical device which is touching the patient. Okay, so for that, you need understanding of all the anatomy, how this problem occurs. So when we talk about the solution outcomes, there are a lot of improving clinical outcomes with 3D models, like I've explained about the pre-surgical plannings. In innovating medical procedure training, so when in a medical device company, when you're working on a new problem, you're not just making a new product, you're also developing an existing device also. So like in automotive, in cars, okay, cars was developed many years back, like a century back. There was used to be a concept which works on 4 wheels, okay, and a motor, right? Now we have come to an era, now we are coming to the EV era, hydrogen fuel, lot of things. But the concept is same, you are moving from a point to the B point. But what are you improving? The lot of improvements has done in all the components which are engineered by a lot of companies. Okay, so Toyota, they have their own USP, Ford has their own USP, Maruti, they has their own USP. They have done their all developments year by year in engineering sections, in engineering departments. So this is where our medical procedure training also comes into the picture, where you are helping the hospitals by making a good product, a good surgical tool, a good medical device, so that they can improve the patient care health. So this is where your knowledge of science, your knowledge of technology comes into the picture, which can help the doctors to improve the procedure trainings. So you can also make the drilling and cutting tool. So like I've explained, if we are talking about a human life, it is not a nail hammered into the wall. You need specific medical tools to operate on the patient. You need specific surgical tools to operate on the patient, right? So on that, who is working? Doctors doesn't develop these medical tools. Who are the developers? They are the engineers. and what kind of knowledge they need. So this is what our hardware looks like. So this is our Stratasys J850 digital anatomy printer, who makes all this kind of possibility where you can make the anatomical models which are biomechanically accurate, and also develop medical device tools, okay, which are biocompatible, which can be used for your preclinical evaluations for all kind of testings and validations. So this is a short video of how this technology works. Audio, it's coming from the projector, it's very low. Yeah, HDMI. So I think you can see here on the screen. Okay, you see here. So this is how your pre-operative planning works. Okay, and what they are holding surgical tools. Even a forceps, it's a mechanical component. If you see as a basic, it's a mechanical component.
How change to system volume? Is the sound coming here from the laptop?
It's मैंने हेडफोन्स पे कर दिया है.
You're targeted.
Okay, so this is, I was explaining about the what kind of mechanical part comes into the picture when you are developing any kind of the medical devices. So you can see in this video how the medical professionals, they are using our technology and the mechanical engineered components. So see, all the surgical tools are always a customized tool. They are first of all the customized tools. Okay, the surgeons, they goes to the lot of industries that they are facing such kind of challenges. They want to develop something which can solve this challenge, and it is not only with one doctor, it goes with all the doctors globally, right? So this is where medical device companies and the team of surgeons, they work together.
Hospitals and medical device companies can create real environments and train in settings that are as close as you can get to the real thing. Experience the most consistent, accurate representation of your targeted pathology while suturing, cutting, inserting, and deploying devices. See how as internal and external forces are applied with blood vessel material that mimics vessel complexities and degeneration with precision, and study the accurate biomechanical behavior associated with physiological and pathological characteristics.
Now how do we, I can speak. No, it's working. Audio is working. Audio is working. Sir, actually when you are putting this on the presentation mode, it is going in the duplicate mode, so the video is not working.
Click on this. This will appear full screen.
Okay. Okay, hello. Yeah, audible. Okay, so when we talk about the blood vessels, so blood vessels are not the parametric models. Those are very complex models, and when we talk about the neurovascular, cardiovascular, such kind of the surgeries, okay, so you need to have that understanding. How does a catheter device works? Why it is required? What kind of problem it is solving? Catheter device, it's a medical device. Now, medical device company, they are working on technologies which can directly digest or intake a pill size of the catheter, and it will go into the particular problem area, and there it will uh, balloon it up, right, and open up the blood clotting or the clogged vessels. So this is what kind of medical device development is going into the picture now. And but why, what kind of issues, but why they get this kind of understanding with these issues? Because doctors, they also need a 3D model to explain the issue. If a doctor comes to you and he tells you that I feel such kind of challenge in this particular surgery, I cannot go deeper into the kidney from this area, from this angle, I need a surgical tool. Will you understand what he's talking, what kind of jargons he's talking about? I will not understand that. So for that, a basic anatomy, a basic, if you don't even know the anatomy structure, you don't require it. But if you see the model, okay, that what doctor is talking about, what kind of problem he's talking about, maybe I can come up with some idea, maybe I can come up with some angled tool or some other kind of medical device which can help me, some robotic surgery also. Robotic, it's a mechanical tool, it's not a medical tool, it's a mechanical tool. Its application is in there in the healthcare, but who is making robotics? Mechanical, right?
Like native bone when force is applied, such as discectomy, drilling, reaming, sawing, and pedicle screw insertion. Even tumors and infected tissues can be added to your bone or organ models in their accurate form, so healthcare professionals can experience the same tactile feedback when performing medical procedures with surgical instruments and devices. Study your patient's anatomy, then plan and execute your approach before ever stepping into an operating room. Reduce the need for cadavers, clean rooms, sterilization of tools, biohazard risk, and other valuable resources. The digital anatomy printer software has a preset anatomy menu with more than 100 options that allow you to print accurate, lifelike models in a few clicks by simply choosing the desired anatomy. Take a step into the world of lifelike anatomical printing. Digital anatomy printing technology. Better preparation, better outcomes.
And so this, that was the most prominent and the you can say the best of the machine that digital anatomy printing can done with a J850 machine, with a lot of hospitals in India who has acquired this technology in house, and they are not just using for patient care, they are using for research work, they are using for medical device development, they are using it for preparing better medical outcomes, okay, and not just the doctors or PhD holders, but also the mechanical engineers who are working in companies like Johnson and Johnson, Abbott, Boston Scientific, Stryker. So there are no doctors sitting in the design department. The design department, they holds the mechanical engineers because they have the understanding how this is mechanically can be done, right? How this surgical tool can be made, an angle surgical tool, what kind of angle I needed, right? What kind of iterations I need to do to make this a better outcome. What kind of medical device I can make for scanning, for radiology, right? For BP check machines, for sugar check machine, for oxygen meter. Who is making that? So this is where your mechanical parts and mechanical knowledge comes into the picture. But for that testings, you need an anatomy structure which is biomechanical accurate, and you need biocompatible materials which can be sterilized, which can be used on a live human, and it can do all the testings. So smart wearables, when we talk about smart wearables, you need a very different kind of materials, okay, which are skin contact compatible. So we have the materials which are the skin contact compatible also, and we also have such kind of materials which are the radio compatible. So when we talk about the radioactivity, so that's a very scary term, but when we talk about the X-rays, CT scan machine, right, and MRI scan machine, what are these? These are the mechanically made machines. They are using the mechanical concept of the electromagnetic waves, right, X-ray waves. So these are the waves, and this is what mechanical components are generating and taking the patient data in the form of the DICOM and providing it to the medical professionals and for the medical device companies. So this is where our one of the materials here, which is a radio matrix material, which is a radio compatible material. So this material can be scanned under any X-ray or CT scan machine and will give you the same output that your original hand will give you. Okay, so this is a specifically developed material for the companies, okay, or for the enthusiast who wants to work something towards the X-ray, CT scan or MRI scanning or any kind of the different kind of the scanning for the human anatomy or for the animal anatomies. So this is the one of the kind and first of its kind material that is available in 3D printing technology. So we also have the tissue matrix material, like we have shown you some videos where you can have that particular feel of the tissues, bone matrix material where you can have the biomechanical accuracy and the hardness of the bone, exact hardness of the bone, and the gel matrix material where you can make the different softness and hardness of the blood vessels. So when we talk about the development here, so not just the technology and software, the third pillar, I always say in 3D printing there are three pillars. First is this technology, second is the software, and third is the material. If either of them is missing, that means you have not chosen the right technology. So you need to find out your problem, you need to find out your application, and this is where all three factors should be compatible to complete your application. So this is where all the materials we are providing to make the anatomical parts. We have the biocompatible materials which are sterilizable, skin contact friendly, where you can also make the smart wearable devices, and also the which are going into the ears or going into the nose, into the mouth, coming onto the skin, right? Prosthetic devices. If you're making any robotic hand, robotic is what? Robotic hand is what? Robotic prosthetics. It's a mechanical part. There are no doctors who are making, there's no doctor engineer, there is mechanical engineer only. So this is where mechanical engineering is coming into the picture. And I have seen lot of prosthetic robotic hand companies, startups coming in the past 5 years. A lot of startups has come from the, even from this city also. Like there is a Aether Biomedical Devices. There are other biomedical device companies also who are working towards the robotic hands. So yes, that was one example. We also have the jigs and fixtures materials biocompatible where bone cutting can be done. We also have the transparent material where you can work towards a microfluidic engineering. So microfluidic engineering also requires a lot of your physics concepts and your chemical concepts. Then we also have the Agilus, which is a elastomer material. And these are some of the materials which provides good engineering materials such as the ABS material, which is biocompatible. So for the very good hardness or very good toughness materials which should be biocompatible, that means it should be good skin contact friendly, sterilizable and ISO certified material, ABS materials, which are engineered materials only for the medical device developments. So these are all the testing and certifications which are materials certifies and complies for all the medical device testings, whether it is related, it is showing I think very small numbers here, but I will just tell you some of the names. So like it is for the skin friendly, it is their mucosal membrane. Mucosal membrane means your tissues under the skin, that is called the mucosal membrane. Okay, so any kind of device which is coming in the mucosal membrane contact, that is also compatible with our machine. Any kind of the cytotoxicity is not there, skin contact friendly is there, sterilization is there, you can use it to make a real life dentures also with full color as a single model, and you can match the color of the patient specific data. So we have those such kind of the biocompatible ISO certified materials also, where you can directly make the dentures. So when we talk about this technology, this material, the software, and for the the complete package solution for medical, there are three open windows which comes into the picture. First is surgical planning for patient specific. So this is where the doctors works more, but doctors comes with some challenges to medical device companies, and this is where they collaborate and provide a solution, a patient specific solution. Second is the scaling models and surgical simulators. So if you go on into the internet and look after for these surgical simulators, you will not find any Indian company. But I know some of the enthusiasts, ingenious enthusiasts, who is interested to start surgical simulators, because this is where your mechanical and your medical knowledge comes together and provide a good solution directly to the hospital and education. Then there are devices for patient specific. So you can make the customized devices, smart wearables, and also, consumer medical devices also, which can be developed with our technology. So this is one of the examples from Department of Neurosurgery. So I think you can see some of the pictures here. They have developed the surgical simulators. So a hospital is developing for in-house for their resident surgeons to train them. So like in mechanical, we have the labs, we have the CNC machines, we have the electronics lab also, right? Where we have all the equipments like the soldering machines is there, PCB boards are there for electronics. In mechanical, we have all the CNC machines, lathe machines, drilling machines, power tools, hand tools, everything to train the students how this particular tool works, how this particular tool can be used for what kind of application. So application is important. So this is where surgical simulator comes into the picture. But this is not, cannot be done without the help of your mechanical. This is also one example from one of the Indian college in Chennai. So this is, you can see they have made a different kind of the models, and I think in this picture you can see this is the section of the knee bone area. You can see this is the software where they have prepared the complete anatomical model. They have provided all the materials here, and you can see this is the output. And this is a single 3D printed when we talk about multi-material and multicolor. So this is the brain area. This is the brain area. This is a photo of that brain area, and this is the final 3D printed part which they have made. And this one, this way you can see the different layers of the skins over the skull. If I tell you that I have in human body there are 4 skins or 5 skins, how will you get to know what kind of softness is there? Okay, so that I can choose a material, so that I can choose a mechanism to penetrate the skull area for the brain surgery, for the neurosurgery, for the tumor surgery. If I don't know that where I'm working, I'm not putting a nail. Again I say the same statement, but this is what understanding need to be done. And this is where not your theoretical concept, but this models helps you to understand practically. You need to understand the problem first for the healthcare. So these models helps you to understand where is the actual problem coming and how you can solve it. Okay. So this is one of the video from one of the colleges in Malaysia who is developing and who is helping their in-house medical colleges or surrounding colleges, okay, to come up with different kind of the ideas in anatomy.
I'm Professor Dr. Vignes Warren, Professor of Neurosurgery and the head of the Department of Surgery at University Malaya. I'm also the Director of the Center for Biomedical and Technology Integration, or CBMTI. So we were one of the first groups that pioneered the use of 3D printing for training in neurosurgery. When we first started to develop our models, we only had printers that could print in a single material. And the problem with that was we had difficulties mimicking skin and bone and cartilage and mucous membrane and tumor, for instance. Once we got hold of Astralis' multi-material printer, we were then able to print models which could mimic, for instance, the texture of the nose, the linings of the nose, as well as the more firm and harder tissues at the back of the nose. And this we found very useful, especially when we were wanting to teach our trainees how to handle various tissues. One of the issues was color.
I'm Yuvraj Kumar Balakrishnan. I'm the Chief Operating Officer at CBMTI. If you look at this particular model here, this is basically done by the C2 machine, which allowed us to print in various different materials, but it was just one color. We then had to basically inject a certain dye into a cavity in order for us to create what's called a tumor.
So the new printer that has come out from Astralis, the J750, has overcome the problem of color. And this allows us to create models with both texture and color variation, with both texture.
So you see, when you talk about such kind of the complexity, so suppose if you are working for a medical device company, you join someone, or you are doing any kind of incubation. If you're working for any kind of the nose surgery, food pipe surgery, how it is connecting, such you can see now this is the intersection. You're not looking at the outer side. Now you're looking the inside, how this section looks like, and how your food pipe area would or your windpipe is connecting in the esophagus, and how it is going in the lungs from nose, what kind of section is working. So you see this kind of complexity, it is not easy to understand with the CT scans, even for the doctors. Okay, they have to go for every layer. In CT scans, you have about 500 layers of the patient data from top to bottom. Okay, but suppose if they have this intersection, how easy it is to understand for you as an engineer or for a medical doctor to explain you in a layman language. If we tell you some medical terms, this is what this is, this is what this, you will not understand. Even I will not understand. As a mechanical engineer, we are not programmed in that way. But if someone explain us in a very simple language, so sir, this is where my problem is coming, and this is lot of medical issues are coming worldwide, and this is where we can create a medical device. Okay, so that becomes easy to communicate between two people from different backgrounds. Okay, so this is where our 3D printing technology helps to understand that particular issue. So this is how these simulator models also being made. So this is from the CBMT, again from the Dr. Vignes Warren, who is the MD, and this is what they have created, and this is a pre-surgical trial of the medical equipments. So you cannot take a patient, you cannot take a live body or a dead body and sir, come please volunteer for us so that I can put a hole in your head and test my medical device. This is not possible. Okay, so for this particular things, you need a model which can mimic. As an engineer, if you're testing your medical device or any developed device, you need a tool, you need a anatomy model. How it is working on the patient skin or the patient body, right? So these are the tools, again mechanically developed tools, right? So you need a testing model also for that. So not just to understand the problem, but For testing of a model also you need these models. Your hard material like PLA and FDM, these are not the suitable things. It will not provide you the good data. So you can see this is the forceps. See the forceps mechanism which is working mechanically, how it is going into the blood vessel inside the head and how it is working the forceps. Okay, how much opening of the forceps is there? Okay, is it obstructing anywhere? Right? Is my developed device is accurate or not? Is the form of the device, the dimensions of the device is accurate? Right? So this is where you have an advantage of using this particular technology. So anatomy creation is necessary for medical, for healthcare challenges to understand the problem, for developing of the product and for testing of the product. So I think we are running a little bit of time, so I'll just go through a little bit faster, but I will explain what case studies are there. So these are from the case studies from the Children's Hospital, where this is a case of a vascular ring in the cardiac surgery. Okay, so in this one, so there's a particular video, I'll run the video, I think it will explain you in a better way.
We're here at Nicholas Children's Hospital in the Heart Institute, and there's a little 13-year-old girl who arrived from Haiti a couple of years ago who was a very, very complicated lesion in her left ventricular outflow tract and aorta, a ruptured sinus of Valsalva into her left ventricle, which is extremely rare, and the anatomy is extremely complicated.
So our goal for every one of these operations is to reduce the total trauma to that patient. And there are three critical structures wrapped around the defect in her heart. Her coronary arteries, her conduction system, the electrical system of her heart, and the aortic valve leaflets. So I have to walk through a little minefield and not touch any of those critical structures and still be able to close this hole inside of her heart.
And being able to do a CT angio on her heart, print three-dimensional models with the Stratasys digital anatomy.
So this is how the pre-operative planning works before the surgery for complex surgeries, so that doctors can use their surgical tools directly on these 3D printed models, because these provide you the same kind of the softness of the tissue, same kind of softness of the skin, same kind of the hardness of the bone and the bone densities, right?
That we can actually operate on and cut and sew. We find that the technology is enormously powerful.
Now, I had been thinking about a different approach, and this model is just changing my mind on that.
And so even before we printed the first heart, we started looking for a virtual reality, augmented reality, now mixed reality solution. Found a wonderful vendor who's a full partner of Microsoft, BSI, Appleclar in Germany, who has a fantastic mixed reality.
So now here you can see a combination of two latest technologies. One is 3D printing, second is your AR technology, right? But both are made by engineers, not doctors. So this is, I'm showing you the output. I'm showing you that how, if you work in a medical stream in a healthcare and comes and solves a problem where it has a social impact, right? So it can solve a lot of problems, and this is where also we as a Stratasys and Design Tech, we take a proud of Stratasys DAP 3D printers, that it is solving the social problems. It is not a gimmick. It is not just creating a toy model or a plastic model where you can just show and just keep it on the table. No, it is being operated on the in the operation theater, on the operation table, for the doctors to have a better understanding. So there are a lot of other examples also, but I will just skip a few. So I'll just show you this example of the orthopedic surgery, which is a mandibular reconstruction using the fibula graft. Mechanically, what you are doing here mechanically, okay? So in the mandibular reconstruction, I think Dr. Ashish from MNR Dental College, he might have covered some of these topics for maxillofacial and mandibular. So maxillofacial is your lower jaw, and mandibular is, I think, if I'm not wrong, I think it's your upper jaw. So reconstruction works comes where it has a very, whether it's an accident case, trauma surgery case, or whether it has a cancer case, yeah, oncology. Now, in orthopedic surgeries, what mechanical engineers roles comes for the development of the tools, right? So, like I said, we are not putting a nail in the wall, right? We need an engineered, medical engineered tool to make a way to cut that particular bone at that particular angle at a very good precision, right? So when we are talking about surgical tools or surgical devices, we are talking about a very high and good precision here. Okay, you cannot go mismatch in microns. If you go mismatch in microns, you can cut a good nerve or a good tissue or a good bone area, okay, which can hamper the patient life. So you need to be a very particular while making your surgical tool angles, its axis, its forceps or anything. So this is where, so you can see in this picture, so this is the engineered or designed part. Okay, so you can see in the mandibular reconstruction what happens, you take a fibula bone, so fibula bone or the femur bone, sorry, femur bone. So anybody knows what a femur bone is? Thigh bone, right? So that is the longest bone in the human body. That's a femur bone. So in reconstruction, what happens? The surgeons, they take a particular area of your femur bone, okay, and they cut down the damaged area. They take the good piece from your femur bone and they fix the bone in the reconstruction work. So they are not using any kind of the outside implant or metal implant or a polymer implant. They are using your own body tissue, your own body material to make the reconstruction work. So for this particular one, if you know the size of this, so this is where the engineer mindset comes. At what angle I am fixing this bone, right? What angle I need to cut the femur bone, what kind of jigs. So jigs, doctor cannot design the jigs. You need a mechanical mind or an engineered mind to solve that problem, that I need that particular jig to cut the bone. At what section I need to cut it, what kind of particular section I need to cut it. So this is where your jig designing for the reconstruction works. Okay, so many of the jigs comes already, these are customized also, and these are general jigs also, which comes for the orthopedic surgeries. So this is one of the examples for the customized surgery here from the Akash Hospital, who owns this particular technology, J850 DAP technology and J5 Mediate. So you can see this is the case of a scoliosis bone. So scoliosis is a problem where your spine is not grown in a right manner. Okay, it is distorted at a different angle. Okay, so you might have seen in somewhere on the internet or somewhere. So this is how the CT scan of a scoliosis patient looks like. Okay, and these are the models with the regenerative ideas on step by step they have made. So these are the 3D printed models. So this is the first model, which is direct patient data. So this is a reconstructed model which where they have used these jigs and the metal implants to put it inside the body. And this is the second surgery model. This is how the reconstruction works in the spinal surgery, in the orthopedic surgery. So here's Dr. Ashish, okay, who is a very renowned neurosurgery doctor, okay, for the complex surgery, for the trauma surgeries, and the Akash Hospital, they handles lot of patients for the complex neuro and cardiac and orthopedic surgeries. So this is where the 3D printing solution comes directly into the picture. They are using MET 610 biocompatible material to make these customized jigs to fit these metal screw implants for the reconstruction of this spinal bone. So anyone can tell me what kind of mechanical technology or idea you need to make these screws or these jigs, which I've explained earlier? Anybody can give any idea what kind of concepts can be added here for mechanical part? Yes. Yes, sir. Yes, first of all, the material knowledge should be there. Springs, yes. Screws. These, yes. Technology also. What technology you will be using to manufacture such implants also? Because these are not just CNC machine and you just put it. That you take a block of a round block and put a hole and put it inside the body. No. You need a very high level of accuracy in mechanical terms. So that was the Akash Hospital. That this is how they are using it. So they have hired one of the mechanical engineer and a biomedical engineer, okay, to convert their DICOM data into STL, okay, and mechanical engineer, he helps to design the jigs for the customized patients. Okay, so this is where the knowledge of both biomedical engineer and the mechanical engineer helps by directly sitting in a hospital and making direct patient care solutions. So this one example is from the Ludhiana Mediways Hospital. Okay, so this is a joint, you can say a project done with the Guru Nanak Dev Engineering College in Ludhiana and Ludhiana Mediways Hospital for a particular patient case here, which is called the PVM, pulmonary malfunction surgery, pulmonary AV malformation surgery. So this is where an engineering college has provided a solution.
Guru Nanak Dev Engineering College was started in 1956. Manufacturing research lab was started in 2012. Dr. H.S. Vidhi contacted us. So he wanted a 3D image of this lung of that patient. My patient was a 23-year-old young man. His parents told me that he had been glued. And there was this mass where the blood was recirculating. That's called the arteriovenous malformation. An X-ray and a CT scan is a two-dimensional.
For converting that particular ICOM images to the STL file, and those files were actually printed in the SE Uprint 3D printer.
I'll show you the print. So this is the 3D print. And all these branches are exactly as they are in the body, because I could not see through the blood, through the lung. This was actually present in our operation theatre. So it just took us, I think, about 1.5 hours, something which would have taken 4 hours. Because again, we had an absolute knowledge of where the artery is. The blood loss was next to nil. This was a great boon to us. Within 2 days, we were able to send him home. And his nails, you will see, are absolutely pink now. So, hats off to technology.
So this is where the collaboration between an engineering college and medical hospital can also be done, okay, by taking the cases from the doctors by collaboration with the surgeons and doctors and provide a medical solution or a mechanical solution directly to the hospital. Okay, so for engineering college, in terms of the research, in terms of helping your surrounding medical hospitals who cannot take a 3D printer or who does not have that skills to understand or to operate on the 3D printer, but as an engineering college, as a research institute, you can do. So this is how one of the college, and this is only one example I am putting up. There are a lot of engineering colleges out there in India who have the 3D printer, where they are doing consultancy solutions directly to the hospitals as a non-profit work, so that it is a directly outcome to the patient care. So this is the outcome of that particular surgical planning, and the advantage of that to the surgeon or to the patient is, first of all, the surgery time was reduced from 4.5 hours to 1 hour only. So that's a very big saving on the surgery time. So the patient has to pay less for the operation theatre room and for the surgery time for the doctor, and doctor also can do a surgery in a less amount of manner. So there is less fatigue to the doctor also. he can manage other patient also, he can take care of other surgeries in his own time. Second advantage directly to the patient is, since the doctor know where the problem was actually coming, okay, he could save a lot of blood loss of the patient, because if there are a lot of blood loss means a lot of recovery time, or you need a blood supply, external blood supply, okay, to the patient. So this is what the advantage of a pre-operative planning directly in the operation room. This is one of the examples from the dental departments of the AIMS New Delhi, where they also make the oral and the maxillofacial cases for the surgery planning models for the complex surgeries. This example is for the dental, so I'll show you a video how this dental model also can be done using the same materials, okay, where you can make the dental implants or dental direct surgical tools also. So when we talk about such kind of tools here, so one of the colleges in Noida, they have a medical department and they have a mechanical department. One of the professor was working with the closely one of the hospitals and surgeons, and they wanted to develop a surgical tool, okay, and that surgical tool was not available anywhere in the world. It was not, that kind of idea was not developed, and there was no product developed around that idea or that kind of the problem. So they developed the tool, okay, they designed that particular product, they manufactured it, the metal part was manufactured with the your manufacturing tools, but the casings, the holding devices and the mechanism, the movable mechanisms, all those were 3D printed, and that was actually tested for the preclinical trials for that particular team of the doctors and the mechanical engineers, the professors. So this is where the research work can be helpful, where you can collaborate with any kind of, with any medical device companies, you can call upon them, you can discuss the problems, or you can discuss with the doctors. This is also few examples of the maxillofacial surgeries. And this is one of the examples for the catheter devices, how these complex blood vessels can be 3D printed with our technology.
The Jacobs Institute is really designed to collaborate with industry and physicians to drive innovation.
So this is a Jacob Institute in USA, who is a anatomy model manufacturer. They collaborate with all the medical device companies to manufacture their particular requirement, to make the anatomical models, to test their devices or for their product development.
We need industry to provide better tools for us to continue to what we do, which is develop tools for physicians to train and test in different clinical environments.
In an ideal world, if you wanted to practice a procedure before you actually do it on a patient, you want to replicate every element of that procedure. You want to know how that tissue is going to feel as you're delivering a device. You want to understand how all the different gadgets that you're going to use for the procedure.
So if you see here, what do you see here? It's a catheter device, right? Here you see a catheter device. So now if you want to test it, you cannot use a rubber pipe from your house, from your kitchens, from your bathrooms and do the testing of this catheter device. You need a biomechanically accurate soft tissue blood vessel material, okay, where you can test the material of this catheter, the movement of the catheter and the working of the catheter at the dedicated area, right? So if this material punctures the blood vessel, that means there is a problem with the design of your product. The movement is not accurate, or the material is so sharp then you need to change the manufacturing method. But how you will test it? You need a 3D printed model, a good biomechanically accurate 3D printed model. And this is also one of the, so I am showing you the complex area of the product development. Simple product development, it is easy. Okay, that can be done with your basic 3D printing also. But when you're talking about the complex problems of healthcare, so this is where our medical solution is coming into the picture. So this is a cardiovascular system enclosure. The company name is
Cardiovascular Systems manufactures an orbital atherectomy device for the treatment of both PAD and CAD. CSI is very patient-driven and patient-centric. We are always thinking, how can we improve our product? And the rapid prototyping.
So you see here, so again, it's a medical device, right? So for this particular medical device, you need your mechanical engineering, okay, right? So this is how your particular very complex medical device developments need the both idea of the medical professional, biomedical engineer and mechanical engineer concepts.
And the rapid prototyping capabilities allow us to get products to market faster.
In product development, we do a lot of front-end development. Most recently,
So this is a complete medical device which they have 3D printed, okay, by fitting up all the electrical components or the mobile components, but this is how they have printed it, or the complete medical device for the testing, for the clinical validation. Now remember, when you're doing your pre-clinical validations or clinical trials, the materials which you're using should be biocompatible and should be sterilizable. There are a lot of norms, there are only 2-3 norms I'm telling you, but there are a lot of norms which you need to clarify, okay, to the government or to the testing teams prior to the trials.
development. Most recently, we addressed a need that we had of a component that we were able to model in a CAD package, print on a rapid prototyping system, and then actually the next week be gathering feedback from physicians on the product.
With 3D modeling, we were able to take actual clinical imaging and recreate their coronary arteries to test our device. And with new material properties, we're able to simulate the actual elasticity of these coronary vessels, but also mix in hard calcified lesions with the harder materials. Another unique feature of 3D printing is that we're able to print clear lesions that both us and physicians can see through while treating with.
So these are microfluidic devices, right? So microfluidic devices also need to follow the rules of the physics. So how the fluid dynamics. Okay, so this is where the concepts of the fluid dynamics comes into the picture to validate your particular medical device testing, whether you are developing a drug material, okay, or whether you are developing a medical device for the blood vessels.
Our device. This allows us to better explain and understand how our device works in different situations.
We're actually able to get the two-dimensional fluoroscopy images from physicians and then actually try to recreate what they were seeing. And not only do we get to the bottom and learn more ourselves, but then we also are able to help build that relationship with physicians as well.
3D printing has given us the versatility to print pretty much whatever we can think of. We started 3D printing these coronary training boards. Every single one of our sales training reps that goes through coronary training was actually delivered one of those. They use those to interact with the circulating nurses, techs, physicians at their own sites and train them on proper treatment technique related to our IFU, our instructions for use. 3D printing has given us the ability to innovate rapidly. You don't have to be dependent on molding processes or machining processes. We've been able to print fixturing, case recreations, test our device from a reliability standpoint, rapid prototyping, as well as components that just help us in our everyday engineering needs.
just by using rapid prototyping, it not only saves us time on the overall project, but also saves us money as well.
So when we talk about the goals that are achieved by using this additive manufacturing for patient care applications, whether it is being used in the hospitals, in educational institutes of medical, or for the medical device companies. So these are the outcomes, or these are the goals that are achieved till far. So the doctors, they were capable to reduce the surgery times, which are the directly patient impact, reduce the risk of the repeated surgery, which is again a directly patient impact, post-operative risk, reduce recovery time, reduce blood loss, reduce anesthesia. If you have taken a large amount of anesthesia, that's again a negative impact on your body. So morphine, anesthesia, these are not the good drugs. These are the numbing drugs, but these are not good in the large quantities. Faster detection of the problems, faster clinical trials for the medical devices, and anatomical models for clinical testings, for your sales model, for display models, for testing models. So thank you everyone for being a very patient listener, and I hope this session gives you a wide range of wide idea how 3D printing is being used by the medical device companies. Don't think it as a doctor or as a patient, but since it has a social impact, so yeah. But think as a medical device manufacturer or as a mechanical engineer, how you can come up with a solution that can solve some actual problems. And this is where also we take a proud with the Design Tech and Stratasys collaboration with this 3D printing technology, that we are actually doing a social impact with the medical device companies and the hospitals who are doing a direct patient care solutions with 3D printing. Thank you again. Thank you everyone.
Thank you, sir. Participants. Okay, we have a doubt, sir. We have a query here.
Sure.
Yes, Saksham, thank you. That was a very well presented. Actually, as we faculty, we are sitting here, a completely of engineering background, as you yourself have an engineering background. Just a small suggestion, as coming from an engineering background, you have a very good terminology in medical. So we just want to know what books or what courses we can refer to make sure that we are also equal to knowledge of medical terminology, because that is the key problem which we face when we interact with doctors. Doctors don't speak in engineering language, we engineers don't speak in medical language.
Right, sir. So yes, so that's a very big obstacle. So even when I started working with some medical, our customers in hospitals and medical device companies, I also used to be not understood very well with all these jargon. These were all jargons for me as a mechanical engineer. But when I started learning with the basics of the medicals. I started learning what medical devices are there in their portfolio, right? So suppose if you go to a website, you find a medical device. This is what I have done, but you can take another route also. I saw what medical devices are coming. I saw what kind of problems they are solving. Then I reverse engineered that particular problem. That this is what this medical device is helping in neurosurgery. In neurosurgery, this is what area it is solving the problem for the doctors. Because at last, you need to speak to the doctors, right? So this is what path I have taken. Then I have learned some terminology on the Wikipedia also. I have learned some things from the YouTube channels also about the human anatomy. So you can find some very good basic terminology videos of human anatomy on YouTube's and even on the websites, some particular medical websites, where you can learn the structure of the human anatomy, that what kind of the brain parts are there. So these we have all learned in the 10th grade biology, 8th grade biology and 9th grade biology books. You can take those NCRT books or state books or any books from the schools, from books from the stores, and the same terminology you can learn. So you need to, for the communication, we need just to have a basic understanding, right? We don't have to go deeper into that. Doctors can explain that very well to us. But yes, for that particular understanding those terms, you can go to the basic anatomy learnings on the websites.
Thank you, sir. Your lecture is very informative.
Thank you, sir.
And moreover, what I understood from your lecture is, so mechanical engineer is the father of all doctors.
Yes, sir.
Thank you very much.